Welcome. In this video, we will demonstrate a distributed Bragg reflector. A distributed Bragg reflector is constructed by alternating layers of two different materials. In this simulation, we will set up 16 layers of silicon dioxide and titanium dioxide. We will set up a broadband plane wave from the top and then measure the reflection spectra. This is a one-dimensional simulation, so we set the domain size in X and Y to 0. To design the DBR mirror, we often need to change the operating wavelength or the materials used. These changes will affect how we construct the geometry of the mirrors. To facilitate this, we've introduced a powerful feature: variables. Under the Parameter tab, you can define custom variables to be used later in the simulation. We have included 5 variables, including the central wavelength as the operating wavelength of the mirror and the indices of the two materials. Using these variables, we can calculate the required layer thickness following the standard design rule for distributed Bragg reflectors. Feel free to change the values of these variables to run your own simulation. Moving on to the structure section, you can use the previously defined variables to specify the index and thickness of each layer, as well as the source of excitation. Now that everything is set up, simply click Run. It will only take a few seconds to finish. Click on the post-run panel to see a beautiful reflection of the operating wavelength. Feel free to change the variable of central wavelength and material indices to simulate your own DBR mirrors. This example is view only. If you have flex credits, you can now save it to your folder. Then you are ready to edit and run your own simulation.